Welcome back to James's Adventures in Advanced Placement AP Chemistry, everybody. We're on 4.3 right now, and we're just going to dive straight into the problem. So strap in your street belts and get ready for some fun. So we're going to start off on page 129 of your textbook. This is number 72, part B. Okay, so the book gives us a Ca3PO42. And our task is to find the mass percent of each element in this compound. So we're going to go ahead and start off same as last time as finding the total mass of the compound first thing. So we find that by doing 40 times 3 plus 30.97 times 2 plus 16.8. And this is equal to 310. So now, we want to do the same thing as last chapter, 4.2. I hope you tuned into that video. So we want to take our mass of each element and divide it by the total mass of the compound. So let's go ahead and start off with Ca. We've got 40 times 3 over 310. Once we multiply that by 100, we end up getting 38.7%. So calcium in this compound takes up 38.7% of the compound. Let's move on to phosphorus, shall we? We have 30.97 multiplied by 2 divided by 310 times 100 for the percent. And performing this calculation, we end up getting 20.0% for phosphorus, which means phosphorus takes up 20.0% of this total compound. Moving on to our last element, oxygen. It is 16 times 8 divided by 310 times 100 for the percent. And we end up getting 41.3%. So oxygen ends up taking 41.8% of this compound. 41.3% of the compound. Very sorry for my mistake there. Moving on to the next question. This is the same question, except it's part C now. So, we have the, it gives us the compound NaHPO4. And again, we have to find the mass percent of each element in this compound. So, let's go ahead and start off finding the total mass of the compound, which is 23 plus 1 plus 31. Plus 4 times 6. And when we perform the calculation, we get 119 for our total mass of the compound. Now for sodium, let's go ahead and do sodium. We get 23 over 119 times 100 to get 19.3% for sodium. Hydrogen is just 1 over 119 times 100, and we get 0.800%. Phosphorus is 31 over 119 times 100, so we get 26.1%. And finally, oxygen is 4 times 16 over 119 times 100, and we end up getting 53.8% for oxygen. All right, next question. Our next question is on page 129 of your textbook. It's number 65. We're going to go ahead and do part A right now. So the book gives us 150.0 grams of Fe2O3, and we have to find out how many moles of Fe2O3 this is. So to start off, we're going to find the molar mass of Fe2O3. So to find this, we just want to look on our handy-dandy periodic table to find that the molar mass of iron is 58.85, and since we have 2 irons in our compound, we're going to do 55.85 times 2, and then we're going to add 3 times the molar mass of oxygen, which is 16. So to find the molar mass of our compound here, we're going to go ahead and do 55.86 times 2 plus 16.00 times 3. And the final molar mass we end up getting is actually 159.7 grams per mole. So to find out the number of moles, we want to take the number of grams that we have and divide it by the molar mass of our compound. So we're going to go ahead and do the calculation. 150.0 divided by 159.7. And we find out that we get 0.9393 moles. So that's going to be our final answer for part A of 65. Our next question is the same question, but we're doing part C this time. The book gives us The book gives us 1.5 times 10 to the 16 molecules of BF3. So this one's actually pretty tricky because we have to find the number of moles of BF3 we have just based on the number of molecules. So here we're going to use something called Avogadro's number. And what Avogadro's number is it's a measurement, it's a constant, and what it represents is the number of molecules per 1 mole of any substance. So in this case, we're going to go from molecules to moles. So we're going to set it up with 1.5 times 10 to the 16th power times 1 mole divided by Avogadro's constant, which is 6.022 times 10 to the 25th power. Maybe it's 26th power. Future me, go ahead and put it up there. Make that edit. Good job. So when we carry out this calculation, we end up getting 2.5 times 10 to the negative 8 moles, or maybe it's different because I made a mistake with Avogadro's number. Future me, fix it. Thanks, buddy. And here we are on to the last problem, still on page 129 in your textbook. We are on question 71, and we are doing part C. So the book goes ahead and gives us, it says that we have 2 times 10 to the negative 2 moles of C2H3Cl3O2. And we have to convert moles to grams. So let's go ahead and find our molar mass of the compound. We end up getting 2 times 12 plus 3 times 35.5 plus 2 times 16. So our total mass of the compound is going to be 189.5 grams per mole. So to go from grams to mole, to go from moles to grams, we're going to have to multiply our number of moles times our molar mass. So we're going to do the calculation 2 times 10 to the negative second power, multiplied by our molar mass, which is 189.5, to get our final number of grams, which is 3.8 grams. That's all I have for 4.3. Tune in next time for 4.4. I'll be back on the mic spitting some sick chemistry. I'll see you then. Bye-bye.